Okay, so you gotta hear this. Google's quantum AI team just dropped something huge, a breakthrough that could literally let us see the invisible fabric of nature itself. We're talking about a fundamental shift in how we understand the world. Let's get into it.
And that really is the central question, isn't it? I mean, from the cosmos down to the molecules inside our own bodies, so much of nature is completely hidden from us. For centuries, we've been building better and better tools to see it, but we've started to hit a wall.
You know, the story of human discovery has always been this quest to understand nature. But the closer we look, man, the harder the problems get. We've kind of reached a point where nature's complexity is just overwhelming our very best tools.
I mean, think about it. You've got these massive supercomputers, machines that can do trillions of calculations a second. And even they just choke when they try to simulate nature. Things like predicting the shape of a new protein for a drug or designing a better battery material. These are the kinds of problems where nature's complexity just runs circles around our classical computers. And that's where these machines come in. Quantum computers aren't just faster versions of your laptop. They're playing a whole different ballgame. They work on a completely different set of principles, designed from the ground up to speak nature's native language. They were literally built to smash through this exact barrier.
So how did the Google team actually do it? How do they break through? Well, they developed this brilliant new algorithm, and they gave it a really clever and kind of intuitive name, quantum echoes.
Just think about how a bat uses sound to map out a dark cave, or how a submarine pings sonar to see in the deep ocean, right? They send out a pulse, and then they listen for the echo. And that echo carries a ton of rich information about everything around it. This algorithm does something very, very similar, but on a quantum level. Okay, so here's the basic recipe for how they create this echo on their 1 of 5 qubit array. First, they run a complex series of operations forward in time. Then, and this is the secret sauce, they perturb it. They just give a single qubit a tiny little nudge. Third, they run the exact same operations, but backwards. Finally, they just listen. They listen to the interference between that forward and reverse signal. That interference, that's the echo.
And that little perturb step is incredibly sensitive. As Vadim Smelyensky from the team put it, that tiny nudge on just one qubit creates a ripple, a quantum butterfly effect that spreads through the whole system. And that ripple is precisely what they're measuring.
So what is this echo, really? Well, the technical term is an out-of-time order correlator, or OTOC. Now, don't let the name scare you. All it really is a way to measure how that tiny little nudge causes information to scramble and spread throughout the quantum system. Just think of it as a special number that makes all the hidden connections inside the system suddenly visible. Okay, so this isn't just some cool idea on a whiteboard. The Google team used this algorithm to set a brand new verifiable milestone in the history of computing, a new speed record. And this is a phrase you're going to want to remember. Verifiable quantum advantage. This is a huge deal because it's the first time anyone has ever achieved it. It means the quantum computer got an answer a supercomputer can't, and they can prove the answer is right. It's a real, repeatable result, a true benchmark for the entire field. So how much faster are we talking here? Well, on Google's quantum chip, this echo algorithm ran 13,000 times faster than the best possible classical algorithm running on one of the world's top supercomputers. This isn't just a step forward, it's a quantum leap into a totally different league.
And that right there, that's the real headline. This marks a critical turning point. Quantum computing is now officially moving out of the realm of pure theoretical science, and it's becoming a tool we can use to actually do science. Of course, a breakthrough like this isn't just about the clever algorithm. It's about the hardware. So let's meet the star of the show, Google's quantum chip, nicknamed Willow. According to Sujin Chan, who directs the quantum processor team, Willow really has 3 key advantages. First, its quantum gates, those are the basic operations, are incredibly accurate. Second, it uses some really clever tricks to cut down on the errors that naturally creep into these calculations. And third, it can take millions of measurements in under a minute. It's just a beast. And just to give you a sense of the sheer scale we're talking about, get this. Over the course of the project, the team performed 1 trillion measurements. That is a huge fraction of all measurements ever done on all quantum computers in history combined. It's just mind-blowing. And you need that kind of raw performance, right?
Because as Suchan Chan explains, it's what allowed them to pull that incredibly faint echo signal out from all the background noise. It let them distill the most important signal from all that quantum static.
Okay, so a record-breaking algorithm, a super powerful chip, that's all amazing. But what does it actually mean for us? What can we actually do with this newfound power?
Well, one of the first places this is going to make a splash is by supercharging a tool that scientists already use every day to map out the shape and structure of molecules. It's called NMR spectroscopy, and it's about to get a serious quantum upgrade. And why does that matter? Well, Nicholas Rubin, who's Google's chief quantum chemist, puts it perfectly. The shape of a molecule is, well, it's everything. It determines how a drug will fit into a protein, how a battery stores energy, or how a material conducts electricity. If you want to design better anything, you have to understand shape. And they didn't just theorize this, they actually proved it. They teamed up with UC Berkeley and put their algorithm to the test. They used the quantum echo to predict the structure of 2 different molecules. Then they took those same molecules into a traditional lab and measured them with a standard NMR machine to check their work. And the result? The quantum predictions were spot on, correct.
You see, this is a really, really big step. It's one thing to do an abstract calculation. It's another thing entirely to create a direct link between that quantum computation and a measurable real-world property. We're finally starting to solve practical problems with these machines.
So, with this milestone in the bag, the team is feeling pretty optimistic. They believe we are now less than 5 years away, so by 2030, from seeing the first real-world applications that are only possible on quantum computers. And that just leaves you with this one kind of mind-blowing thought, right? We've just heard the very first faint echo coming back from the quantum world. What secrets about the universe, about new materials, about life itself, what will be revealed when we can finally hear the full sound?